Oh, yeah. Thanks. Shut up.
Yeah.
You need it in writing. Okay. Important, and you're going to think, didn't we already talk about this? But it's completely different. Important aircraft engine lubricating oil properties. Engine lubricating oil properties. And I believe a lot of these are kind of focused around some of your Q&As. And they ask questions about oil. And this is what you're going to see. So the first thing is gravity. I think it's not supposed to have a gravity, doesn't have an effect on it or something. No, that's not it. A numerical value, so what is gravity? A numerical, close. A numerical value which serves as an index of the weight of a measured volume of the product. So a numerical value which serves as an index of the weight of a measured volume of the product. Of the product. So you're probably familiar with this term, specific gravity. Why is that not fun?
Chemistry.
We're going to make it fun-ish. So specific gravity, the weight of a substance when compared to what? You know what I'm going to say?
Gravity.
Close. When compared to distilled water. Have I told you my distilled water story?
I would say I wouldn't want to hear it.
Wait, who's had electricity? Oh yeah. 'Cause
Oh,
you,
yeah.
Yeah.
The guy at the farm and the water from the sink.
The water in the sink and
Dirty water.
dirty water, but he thought distilled meant that it sat there for a long time. It was distilled.
Still water.
So, well, if that's the case, distilled, wouldn't that mean you shook it up? I don't know. But anyway, he was dead serious. He thought distilled water was just something that...
Still water.
Yep, distilled water. So what is distilled water? Distilled water has a specific gravity. So that's SG, specific gravity of 1.000. And weighs 8.328 pounds per gallon. And I tell you that so that I can tell you about oil and fuel. If I have water, oil, fuel, and I pour them all into a bucket, what are they going to do? Separate. Okay, what's going to float to the top?
Yeah.
Gas.
Oil.
Gas and oil.
Yeah.
We'll get to that. And then water at the bottom. Okay, so aircraft oil, or oil. Aircraft oil has a specific gravity of about 0.9 and weighs, and I think you have to commit this to memory, weighs, technically it's about, but in aviation we say 7 pounds per gallon. Let's put this, 100 low lead is 6 pounds per gallon. So now which is lighter? That's 100 LL, low lead, fuel. Aviation fuel. Fuel is 6 pounds per gallon.
Huh. Less dense.
So less dense. So which goes to the top?
Fuel.
Fuel, then
Oil.
Then oil.
Water.
yeah. When I was in the Navy, after I got out of active duty, I taught firefighting school. And when I was like really new, we took 5-gallon buckets, steel buckets, and we put diesel in them. We'd light them on fire, and then we just take a long ladle, cup and thing. We'd throw it out on the ground, and then just, be burning. And we teach people how to use fire extinguishers and stuff like that. Which I'm just thinking, we did that inside the county, city of San Francisco. So we have big black billowing smoke in San Francisco, right on Treasure Island, which, no way. I mean, that's, But anyway, so you have to light the diesel on fire. You ever tried to light diesel on fire?
It's hard.
That stuff will put out a match. It makes a good firefighting liquid practically. Don't do that.
Good water.
So we had just a regular gas pump. One side was diesel, one side was gas. So you fill it up 2/3 of the way with diesel. Then you take a little gasoline, just squirt it on top, and of course it stays on the top, and you light the gasoline on fire. Well, the first time I did it, I used just a little too much gasoline.
Oh.
Whoosh! Nobody saw it. I'm cool. I still have a little. I feel some hair up there. I think we're gonna get away with this.
Doesn't diesel have to be atomized in order to actually ignite?
Well, that's gas is atomized. That's what's igniting there.
Yeah, but you can put a match on the gas and all.
It's flash.
Because
it's at what point
it's already
does it
flashed.
emit like enough vapors for it to
Yeah, I mean, you
combust
put
on its own?
put gas down and just look at it. You can see the vapors rising.
Yeah.
All right. Speaking of that,
Flashpoint.
flashpoint. This is not the point at which Tobias lifts his shirt up. It could be. I mean, this doesn't rule it out, but that's not what I'm talking about. All right, flashpoint. Temperature at which an oil must be heated, or any substance heated, to give off enough vapor to form a combustible mixture above the surface that will momentarily flash or burn. So momentarily. So temperature at which we'll just say a fluid, probably doesn't have to be a fluid, must be heated. Technically it's oil we're talking about, so that's the word I have here. Oil must be heated to give off enough vapor to form a combustible mixture above the surface that will flash, that will momentarily flash or burn when exposed to a flame.
What do you mean above the surface?
Those vapors start
Oh.
forming above the surface.
The gas is better.
So that is flash point. So what can we say about aircraft oil? It should have
Very low flash point. Or very high flash point.
aircraft oil must have high or low?
High.
Why high?
Because you don't want it to combust.
High temperature flash point. That'd be another way of saying it. A very high, I'll just put temp flash point. So you know which way it goes. So that's temperature. So yeah, if you had a low flash point, I mean, that'd be kind of cool. Every now and then your engine just explodes. Oh, well, that's flash point. Yep.
Well, that was
Why
cool.
didn't you change
It's like
the
Uncle
model?
Buck's car. Remember that?
Now, I will tell you this, that I don't know if I have mentioned this here or later, or not even at all. Aircraft, a lot of aircraft have oil dilution systems, especially older radial aircraft. Our 310 out there, it's got oil dilution built into it. I don't know if it's operational or not. But in aircraft, an oil dilution system simply takes fuel from the tanks and pours it into the crankcase. Just dump fuel. So you mix the fuel and the oil, and it makes the makes the oil thinner. Right? So right before you shut down, you just pour a bunch of gas in there, and now you got thin oil. So, woohoo! So you have thin oil, which is going to be fantastic for starting up. And then it works great because as you start to get warm, those fuel vapors start to evaporate. They find their way out of the breather line, and then they're just gone. Unless there's a spark.
Yeah, it seems problematic.
And then it whoosh. And then I'm like, whoo. All right, so there's flash point, and then above that is fire point. So that's the temp at which oil must be heated, or the liquid be heated to give off enough vapor to form a combustible mixture above the surface. So blah, blah, blah. That will burn. Can I do that without screwing you up? It's the same thing, at which it must be heated. Heated, let me see. Yeah, I'm trying to save time. This is going to cost me time. Well, must be heated. Forget it. To give off. I know better. Enough vapor. Oh, I'm not going to Seaworld now. Vapor to form a combustible mixture. Let me just cut and paste here. Mix above the surface. Combustible mix. I'm gonna skip the part that will continuously burn when exposed to a flame. And of course we would want oil must have a very high fire point. All right, we talk about viscosity. So we're going back to father-in-law's theory of oil. He talks about viscosity. So, you've got your 10 weight, your 20, 30, 40, 50. He said, well, you just think about those as the size of the ball bearings. So your 10 weight, little tiny ball bearings, and 20 is a little bit bigger, and 30, 40, and the heavier the oil, the bigger the ball bearing. And in theory, of course, I used to use that. If you have a car, and as you get up in miles, you would assume that it's wearing in there. You need bigger ball bearings to fill those spaces, and that is true. In aircraft, we tend to monitor the pressures a lot closer, and that's exactly what people do with aircraft. We'll start out with the recommended oil, and then as it wears down and the oil pressure starts dropping, and we keep adjusting, and it won't stay up. And it'll just pour heavier and heavier oil in there. Oh, look, problem solved. Bigger ball bearings. It's all ball bearings these days. You guys don't even know what movie that's from. Fletch. This is a Chevy Chase movie. He's an aircraft mechanic, pretending to be an aircraft mechanic. Viscosity, the resistance the oil has to flowing. Resistance the oil has to flowing. Resistance the oil has to flowing. There we go. High viscosity. High viscosity oil pours slowly. Why, you disagree with that? Man, I don't want to write that. You don't have to. Low viscosity oil pours faster. Yeah, got that? All right, so far. It is tested. How do they test it? How do you get the viscosity? it is tested with a Seaworld universal viscosimeter. That's what you wanted to know.
What?
I want me to write it?
Yeah.
Seaworld universal. The entire universe got together and figured this out. Universal viscosimeter. All right, here's the weird part. So we have aviation, the aviation number, that's not hashtag, and we have the SAE. What is SAE?
Society.
And I just wrote C. I want to go to Seaworld. SAE. Come on, what's SAE?
Something automotive engineers.
Right on. Society of Automotive Engineers. So,
Society with an S.
huh?
I
Yes.
don't know. Never mind.
So you go to the store and you buy, what kind of oil you guys getting?
0W20.
0W20, 20W50, 10W40.
Mystery oil.
Those are all SAE numbers, okay? But they're multi-grade, so we can also get straight weight or not multi-grade, which very few people get, but we'll talk, it's easier to look at that. So these are some of the SAE numbers. You go to the store and you get oil. You got 30, 40, 50, 60, 70. That's pretty heavy stuff right there. I don't think I've ever seen 60 or 70. Well, in aviation, we don't like to use those numbers because we want to be different. So our equivalent is 65 weight. And you're going, okay, this is going to be a problem. But then everybody got on board and they said, well, wait a minute, this is going to be a problem. Okay, well, let's fix it. Let's just double it. So 40 can be 80, 50 can be 100, 60 can be 120, and 70 can be 140. So with the exception of this little outlier here, it's like, why'd you do that? All right, and then to make things easier, everything in general aviation is right here. Except for radials. And radial engines would be radial. They would be down here. Can be. Don't necessarily have to be, but. And a very wore out, I talked to somebody, not somebody I necessarily agreed with or respect. Their engine was very wore out, so they said, oh no, it's no problem. We're just running radial engine 120 weight in the aircraft. All right, so yeah,
Oh, what is 65 used for then?
I'm sure it's out there.
Oh, okay.
I don't know. Maybe it's not. In all of the brands that I'm going to talk about and everything, you'll notice I never go below 80, and I'm never going to go. Once I'll go above 120. I'll hit 120, but otherwise it's all between 80 and 100. You're like, oh, look at that. Am I forgetting? Nope, this is the way it is. And you remember a lot of this stuff, aviation, is way back. Happened a long time ago. All right, so we're like point number 1, still under the tested with a Seaworld universal viscosimeter. So what is viscosimeter? How long it takes. How long it takes 60 cc. What's cc mean?
Cubic centimeters.
Thank you. Cubic centimeters. All right, saving time. You know what I'm going to do. Seaworld. Does anybody not get the Seaworld reference? Okay, good. Everybody's going to get that. Don't be ashamed. I'll explain it to you. Okay. To flow. Flow at. You don't remember? It's the office thing?
No, I totally remember.
Oh. Flow at a.
Yeah, he just wants to say it again.
I'll play it again. At a given temp, not to now. At a given temp. And they do it at 100 degrees, 130 degrees, and 210 degrees F. Through an orifice. Obviously a calibrated orifice, and then these numbers are how long it takes. Numbers are then and given a value. Or a number, I should say. All right. given a value / number. Oh, I do talk about that. I move over?
Yes.
All right. This is still under that heading. I should have just made a new one and put random facts, but whatever. I have an incomplete sentence here. The oil with a change in its temperature. I don't know, so we'll start with this. Typically, the colder the environment. It's time to go. I can see it. COL. Colder the environment, the lower the viscosity. The higher the temp, the higher the viscosity.
Engine oil is rated backwards. The small number goes to big, like 0 W.
Okay, did I write that? Typically, the lower the viscosity,
Wouldn't
the
it be-
colder the, yeah. Oh, that wouldn't make sense.
No, it's a
The lower the viscosity,
higher
number.
viscosity.
Number, there we go, that makes more sense. Number, and the higher temp, the higher the viscosity, number. I like that better.
Okay, so the lower the number,
So-
the harder it is to flood.
So, all right, so cold weather. So in the cold, I'm going to want like an 80 weight.
Okay.
Cold weight. But if it's going to be hot,
Well,
I'm going to want 100 weight.
Yes.
And then I talked about some older aircraft had oil dilution systems. Oil dilution systems. Yeah, to counter the. Well, that's makes sense to me. All right, some older aircraft were equipped with oil dilution systems to counter the higher temps needed to effectively pump cold oil, which I don't really like that. That oil dilution systems, I'm going to put for cold starting. Cold starting. It's kind of a given fact that, it doesn't matter. If you have no oil, you have no oil. And having no oil is very, very bad. So if you start up your aircraft, which, mind you, is an air-cooled engine, unlike your water-cooled engine, you actually have a thermostat that shuts down the water going through the engine, so the engine heats up faster, then the thermostat opens and the water flows, right? That is correct,
Yes.
right?
Yes.
Okay, good. In your aircraft, you can't necessarily shut down the air. And I say necessarily because, like, my airplane has cowl flaps, but they're only so effective, and they're just on the bottom of the aircraft. They'll drop down, which the air comes in. We'll talk more about cooling, but the air comes in the front through the cowl openings. It's pressure. It's called a pressure cowl, so it pressurizes the top of the cowling, and then on the bottom you have an actual Venturi effect, or a negative pressure caused by the lip that's put in the cowling. So that negative pressure sucks the high pressure down across the cylinders and down and out. Or if you just have a radial engine, they're just out in the open and air goes through them, right? So it's one of those two things basically. So yeah, I can close my cowl flaps, but it's only so effective. If I'm sitting there idling and my oil is so cold that it won't pump and it's basically congealed, and it's like, like butter going through your arteries, I guess. So
Butter on not a bald monkey.
yes, like a donut through a fat guy, man. It just just doesn't move through the arteries, right?
No.
So yeah, so if the oil's too cold, you will oil starve the engine. You oil starve the engine, you're gonna break it. So that's bad. So you got to get so in the extreme cold environments, you got to dilute that oil. you know, I'm thinking about if I had an airplane with an oil dilution system, and I was flying into a cold environment, like, you know, when I flew across the country and I'm landing in like Kansas City and it was pretty cold there. It's like, well, I don't even know what the formula is. How long do you sit there and hold that button and dump fuel into your crankcase? I don't know. I'm sure the POH would tell me if I had it, but that just
Once
seems.
it starts
It's like an old
Yeah.
carburetor, you know, just pour a little bit in there. When
Yeah.
A fire comes out, you better watch out.
So when it blows up, that back off a little bit.
Yeah, when it starts leaking out of the cakes.
When it's full,
Yeah.
instead of a little double. Oil dilution systems would pump gasoline, would pump fuel into the oil tank, into the oil tank, which would dilute it, which would dilute the oil and make it thinner. Keep in mind that, you know, we're kind of at this point somewhat automotive focused, or even if you get into a normal aircraft, Cessnas and whatnot, we're still thinking of an engine with a sump, oil sump, but a lot of engines don't have oil sumps. They do, but they're dry sumps, and so only a little bit of oil's down there and it's sucked right out of that sump and it's headed over to a tank. And so mounted on the firewall, you'll have 5, 10, 15, 20, 30, I mean a lot. You can have a lot depending on the radial engine. A tank of oil, like the V-tail Bonanza out there, I think it's like 2.5 gallons mounted on the firewall. So it's different. The oil is somewhere else. So you're putting the fuel in there. Although the 310 out there is not that way, and the oil dilution does go into the sumps. So let's see, 5. The fuel would evaporate. The fuel would then evaporate when the engine was warm, and the oil. This might be a Q&A. If the oil dilution valve leaks.
Does that mean it sticks open?
Yep. What's going to happen?
All the two things.
Okay, well, and then what's the pilot going to notice?
Loss of
Fuel?
Okay, fuel leaks into the oil when it's not supposed to, right?
The oil tank.
And cause. Okay, now we're just going to talk about what happens when you have inadequate oil.
pressure.
Okay, what about the pressure?
Doesn't
Goes
get to
down.
the right places. Doesn't get to the places it needs to be.
Well, the pressure goes down too, though, because the oil's thinner now.
Okay, it's
diluted.
thinner. So what happens with thinner oil?
Less lubrication.
Okay, what's that going to do to the engine?
Overheated.
Overheat. So, in oil and causes low oil pressure and high oil temp. So remember, the aircraft, we're monitoring our oil temp. Don't have that in a car. All right, back to non-random facts. Viscosity index. Back to the oil properties. What are we looking for? Viscosity index of an oil is its measure of its rate of change of viscosity. Viscosity, let me see, write this down. Viscosity index is a measure of the rate of change, measure of the rate of change of the viscosity. Change of the viscosity as temperature changes. So the higher the index, the less the change. So a high index is a good thing. Want it to stay stable or do what it's supposed to do. Color. Color is a big deal in oil. For whatever reason, at least in general aviation, is not something we monitor. Back in my Navy days, I wasn't in aviation. I was shipboard, but we had a lot of equipment, very expensive equipment, obviously. And one of the jobs on one of the watches I stood was every morning you had to go around and get samples of oil from all these different machinery, and you would take it down into the main engine room where they had a big light board, like you were shoving X-rays up or something. You had to put them all up there, and then chief engineer would come down, look at the color of all the oil, and kind of evaluate it. Obtained by referencing. I guess we do the same thing, sort of. A transmitted light through a sample of oil. Now, does anybody take out, get your dipstick, which in an aircraft is called an oil level gauge because we're fancy. It's like the cigar lighter. So we take our oil level gauge, which dipstick, take it out, and kind of look at the color of that, and kind of evaluate it. You do that?
Yep.
Yeah. So if it's good, you're like, fly it a couple more hours.
Keep going.
Nah, we don't really do that. So cloud point. Whoops, this is going to get off now because that's off. The temperature at which, the separation of the wax in the oil becomes visible. Temperature at which the wax in the oil becomes visible. And that is usually right above, temperature is right above the solidification point. So we're talking cold. So first you're going to get some wax. Wax is going to separate out. Then your oil is going to start to kind of go a little bit solid.
Kind of like bacon grease. It starts to cool.
Yeah, bacon. I like that. Damn it, now I want bacon. Okay. You got to watch me because now things are off here. Pour point.
Talking about bacon
I wanted bacon ever since the bacon slide, so.
Yeah.
Pour point. The temperature, the temp at which oil flows without disturbances. It means it flows nicely. So the temp at which oil flows without disturbance.
I wrote the wrong pour.
Without disturbance.
I used a different lifestyle.
I. Chemical stability. Here's the last one. Okay, resists oxidation. Breaking down and coking. All right, so these are all the things that we want in our oil. Good chemical stability, low pour point, pours easily even when it's cold. With the cloud point, we just have a thing, got good color, viscosity index, talked about all that. I cut out this entire page, which may screw up my outline later. But I had 0.5, need for lubrication. This is redundant. Why do we need lubrication?
Because it lubricates.
Yes, which does what?
Keeps things cool.
Reduces friction, which,
Keeps things
okay,
wear.
friction causes heat,
And wear.
consumes energy, causes wear. What kind of friction do we have in an engine?
Dynamic.
Nah, just think of what kind.
Static, rolling,
Rolling friction. What's rolling friction?
ball bearings.
Rolling against ball bearings.
All bearings.
Ah.
All right. Sliding. Where do we have sliding?
Piston.
Pistons and rings.
Uh-huh.
What else?
Tappets.
Tappets. Wiping of the tappets. Good one.
Crankshaft.
The,
Kind of
Like
a-
the German cars.
Rocker arms. Yep. Gears. Gears wiping together. They wipe. Let's see, rolling friction, wiping, sliding. Okay. Let's see, characteristics of aircraft oil. We already got that. We have to have the proper viscosity. We have high anti-friction characteristics, maximum fluidity at low temperatures, minimum changes in viscosity with changes in temperature, high anti-wear properties, maximum cooling, maximum resistance to oxidation, non-corrosive. There, I think we covered all of that, and that would be redundant to write that all down, would it not?
Yes.
So 0.5, which is kind of over to my left a little bit. Types of aircraft oil.
So before we get into it,
Yes.
for PowerPoint, did you mean to put without the servants, or is it?
The temp at which oil
Yeah,
flows
it's
without. That would make more sense.
Thank you.
All right, so we talked about all that. Now let's just get right down to the nitty gritty. You go into the store, you got to pick out some oil. What are you going to pick? Chevron.
Aeroshell 100.
Aeroshell 100. All right, well, there's a couple different flavors, if you will. So first we have what we call the straight mineral.
Baskin Robbins.
Straight mineral, as opposed to ashless dispersant, which we'll talk about a little bit. So, straight mineral oil. Example. And this is not all of the examples, but the most common ones would be Aeroshell 80 and Aeroshell 100. So in I said the flavor, if you will, here, in a nutshell, you start with straight mineral oil and the product, and then you add additives to it, and then it becomes called ashless dispersant. So this is straight mineral, meaning it has no additives. It's just regular old, just mineral oil. And the whole point behind this just mineral oil was, we called it break-in oil. All right, and so the manufacturers want you to break in an engine on just straight mineral, not the ashless dispersant or the detergent oil, some people would call it. We don't really in aviation, but you could. The problem as I see it is that, if, of course, before you do this, first thing you have to do is you have to look at service bulletins, and you're going to have to see, you know, what is Lycoming, what do Continental recommend. And, of course, Lycoming, they're going to say, well, break the engine in on mineral oil, Aeroshell 8, it won't specify a brand, but they'll say a mineral oil, a straight mineral oil, except don't do that in our H or 76 series engines, the H2ADs, or the 76s are called, the integral, if I remember correctly, and don't ever do it in a turbocharged engine. So then you got to step back, you know, okay, what's different between the two engines? Well, the 76 series, the H2AD, and I'm just going off memory now, I'm pretty sure that you were not supposed to use mineral oil. Maybe I wrote it down. I don't know. Maybe now you can, but at one time I'm pretty sure you couldn't. But definitely not turbocharged engines. What's different between those two engines than like what you have? Has a turbo. A turbo does not like this mineral. So, well, it didn't say that. It just says that. So now you're kind of left to step back and go,
Why?
well, why? What's going on?
More
So-
air.
Um,
Kind of more coating, right? Like you said.
Okay, well, we can look at it turbocharged and just say, well, what's happening? Well, number one, the cylinders have more compression, right? And it's going to last longer as we go up into altitude. It's going to think that it's down low, and so that's going to put more pressure on the rings and force the rings out. So perhaps that extra pressure is helping with the break-in, pushing the rings out, so we don't. But remember, it's don't use mineral. You can't. So is it that mineral oil isn't good enough at that point? Also, what else do you have on a turbocharged engine?
Extra oil line?
a turbocharger, which does have those bearings in the turbocharger, which must be lubricated well, or it's going to seize that up. So is it that the straight mineral is not good enough for a turbocharger? Okay, so then are we saying using this straight mineral oil, does that mean the engine won't break in? I'll break in fine. Well, then why do I have to use mineral oil on a normally aspirated? I don't know. Just laying it out there for you. We'll talk more about that. You'll be like, wait a minute, the puzzle's I'm gonna unravel all that. So okay, let's talk about the straight mineral here. So those are my examples. Phillips makes one. I forget what it's called because I never used it. It's like Phillips M or something like that. Made from dinosaurs. That's what I know. Made from high viscosity index. High viscosity. What does that mean again?
Doesn't change in heat.
Yeah, it's more stable. That's VI, high viscosity index, VI base stocks.
So it's got high resistance to flow.
Viscosity index.
Viscosity index.
High resistance to changes.
It contains almost no additive.
What does that say, base stacks?
What? Made from high viscosity base stocks, STO stocks. Contains almost no additives at all. No additives. Just a pour point depressant. A pour point depressant. For improved fluidity at cold temperatures. At cold temps. All right, when do we use this oil?
Break it.
Okay, used for break-in. But not on turbo engines. That's really more of a Lycoming thing. I don't think Continental says anything about that, if I remember correctly. All right, mineral oils. Mineral oil. Yeah, straight mineral oil does not, so not all mineral oils, it's this mineral oil here because it has no additives. Mineral oil does not suspend particles. And allows sludge to build up.
That means it doesn't carry.
Yes.
So any bad stuff that will just drop.
Drops it, dumps it out. So that's, as Tobias points out, as opposed to something with additives, which kind of the way I like to envision it, is it will sort of encapsulate the particles and carry it with the dirt and nastiness and carry it with it, at least into the filter, if it can get rid of it in the filter. If not, it just carries it and it's just stuck in the oil, which is good because when you drain the oil, out goes the bad stuff. But with mineral, it doesn't hang on to it, it just slings it all over the place, which if it settles to the bottom and you can drain it out with the sump, that's great. Use caution when converting an engine that is operated on straight mineral oil for several hundred hours. I should write this, it's good stuff. So use caution. Use caution when converting. Converting an engine that has been operated. Engine that has been operated on straight mineral oil quotes, several hundred. I put that in quotes because I don't have an exact, that's just what the service bulletin said. Several hundred hours. AD oil, that's ashless dispersant, will loosen sludge. And potentially block oil passages, which means higher oil pressures. That's okay.
It's funny that you use kind of like the fats and like clogging arteries, so that's kind of what that is.
Oh, yeah.
You go through and it cleans out your arteries, it loosens any sludge in there.
It actually says to change oil. If you're going to do that, change oil at 5 hours, then every 10, and every 10 until no sludge is found in the screen.
Is that with AD oil?
When you've been running on a mineral for several hundred, and then convert to AD, you got to change it every 5 hours.
Okay.
Change it at 5, then every 10. That's very expensive, by the way. It's incredibly expensive.
How much is it to do an oil change?
I don't even want to know. Is it $7 a quart?
And how many quarts?
10, plus a $30 oil filter.
So $100 roughly.
Cheaper than the truck.
Unless you're paying a mechanic to do it, then you're going to add another couple $100 in labor to decal it.
Yeah.
When I bought my airplane, and my airplane had typically you only use mineral oil until oil consumption stabilizes, which is less than 25 hours. So the first oil change, I'd go 25 hours, dump out the mineral, switch over to ashless dispersant. My airplane had like 100 hours, and the guy was still using mineral. He didn't know any better. I'm like, yeah, kind of low on oil. Well, here's some extra oil. I'm not going to use it. I'm like, well, it's Phillips M. It's mineral. Well, that's what they told me to use. Well, okay.
Okay.
So I flew it home, and well, actually, I flew to the first place and got, switched. I started right away. I needed oil. I'm like, no, just give me, ashless dispersant. And I started right then and there. Got it home, dumped it all out, changed oil as soon as I got home. No point in using it. I want the good stuff. That's a good place to start. So, when I talk about stuff like screen, some aircraft only have a screen, like, window screen, like you guys, your engines, if you looked at it, it's just a screen for oil, and it's only going to catch big pieces. Other aircraft have a spin on, just like your car, but much bigger. Mine is that big. But the one on my wife's Nissan, I swear you'd swallow it if somebody left it laying there. It's like, it's like that. I don't know. No, I'm just kidding. But they're really tiny. But yeah, aircraft are huge. All right, that's it.
Don't go